Hey guys, I'm Miuccamatics and welcome back to my YouTube channel Miuccamatics. Complement of a subgraph with respect to a graph. Let G of V, E be a graph and let G prime of V prime, E prime be a subgraph of G, where E prime is a proper subset of E. Then the complement of G prime with respect to G is another subgraph G double dash of V double dash, E double dash of G, where E double dash is E minus E dash and V double dash is a set of all vertices that are incident with edges in E double dash. A proper subset means a subset wherein E dash is not equal to E, but it is a subset. That means there is at least one edge which is not in E dash. Basically what this is trying to say is just like in the previous complement, here we subtract the two edges. So basically it is the difference of the two graphs, and the second condition is V double dash is the set of all vertices that are incident with edges in E dash. So you need to make sure that this condition exists, satisfied. So in other words, it must not be an isolated vertex. It has to be incident with an edge. Write the complement of the following graphs with respect to the graph G. This is the given graph, and each of these questions are the subgraphs. So find the complement of the subgraph with respect to the main graph. So this is the subgraph given. So basically we subtract the edges in the two graphs. So from the main you subtract the subgraph edges. So in this case there are no edges, hence every edge which is present in the graph G will come in the complement of graph G with respect to the subgraph. Only thing, the vertex V2 is an isolated vertex. Hence, because of the second condition, it must be incident. Therefore, vertex V2 won't be present in the complement. Now in this example, the two graphs are the same. They are equal. So if you subtract each edge, all the edges will be absent, hence even vertices will not exist. Hence there will be no complement in this case. In this third example, E1 is removed, V3, V4 is removed, V4, V5 is removed, and V3, V5 is removed. So what is left is V3, V1, V1, V4. For the same reasons, V2 is not present. And in this example, also we remove V1, V3 and V1, V4. Hence we get the remaining graph. V2 is not present as it is isolated vertex. These are directed graphs examples. This is the main graph and these are the given subgraphs. So we find the complement, which is basically the difference. So V4, V3 is removed, V4, V3 is removed, hence the leftover graph is this, and V2 is isolated, hence it's not included. Here V1, V3 is removed and V3, V4 is removed. But if you notice, it is not present in the main graph. Hence the complement will be the entire graph except V2 is not included as it's isolated. Here V1, V4 is removed, V1, V4 is removed, hence the leftover graph is this.